Okay, guys, congratulations. If you have made it this far, listening to all of them, that's a lot of videos. Or you might have just skipped through and said, hey, I want to do number 10 and found the video. But no matter what, I appreciate you being here and following along. So question 10, similar to 9, except this one here, based on the information given, we are going to be forced to use law of cosines as opposed to law of sines. So if you look at the picture, if you look at the story problem and imagine the picture, she's going from Columbus to Atlanta, Atlanta to Phoenix, and then from Phoenix back to Columbus. During that flight, she's created a triangle, and the only information about the triangle given would be the distances from each point A to B to C and back to A. And the question is asking to determine the angles created during that flight path. So I did go ahead, I actually had this entire video created, and through a technical difficulty, I have to redraw it and remake the video at least. So the first video, 15 minutes, it was like 14 minutes and 50 seconds. So part of that was just drawing the pictures and writing all the stuff out. So what I'm doing is I'm setting it up so that we're listening and just watching the blank sheet, and then all of a sudden like this, I'm going to go poof, and there's the problem done about halfway. So let me just recap. We have C for Columbus, we have A up here for Atlanta, and P for Phoenix. The distances given in the problem are drawn out in the triangle. And again, what I emphasize is that we are going to be forced to use law of cosines. And the reason is, if you were to use law of sines, you have to have at least one angle, because otherwise your ratio of side to angle and side to angle, you have to have at least 3 variables known, meaning you have to have at least one angle known. So we're going to use law of cosines, and law of cosines in standard form is c squared is equal to a squared plus b squared minus 2ab cosine of c. Well, I have labeled c and a, but I have a p. So what I'm going to do is I'm going to call c in my picture the same as the c in this equation, but I'm going to redraw the b, and I'm going to call it p for Phoenix. So what that does is we write the equation such that the side c corresponding to angle c, we're going to call that 1583. So 1583 squared is equal to the other two sides squared, 448 squared plus 1667 squared. So when you lay it all out, and you can pause the video at any time, you'll be able to see where those numbers associate to the letters at the beginning. But after that, it just became a hassle of writing out all the numbers. 2.5 million is what's equal on the left side. We got almost 3 million, 1.5 million times cosine of c. The emphasis I want to put here, though, is when we have this number here, 2.5 million, equal to 2.9 million minus 1.5 million cosine of c, we cannot, at this point, take the 1.5 million and really do anything with it. Like, we can't subtract 2.9 million minus 1.5 million. This has times cosine of c attached to it. This doesn't. Well, what we can do is in orange. We can subtract 2.979 million from both sides. And what that does is it leaves us, first of all, with negative 473,000 on the left, because we had 2.5 minus almost 3 million. So, but what that's going to do is it's going to leave us with just the cosine times 1.4 million on the right side. So what we have here, negative 473,000 equals negative 1.5 million cosine of c. From there, we divided both sides by the negative 1.493 million, and you get negative divided by negative, we get a positive 0.317 equal to cosine of c. The next step is to undo cosine on c. We get arc cosine of c is just c. We get arc cosine of this. We plug that into our calculators, and we find that c is equal to 71.5 degrees. At this point in the last video, we were a solid 10 minutes, maybe more in, so I'm glad we're halfway there. what we have to do with this information is we need to take and sure, we could go back through and do this whole thing over again with, say, law of cosines at angle A or at P. But it's going to be easier to set this up as the law of sines, and that's going to help reduce this need for the hundreds of thousands and millions numbers. So let's do that. There's the ratio. Sorry, I decided to pause the video and just set it up again to save some time. But anyways, as I was saying, we're going to take sine ratios, law of sines. It's going to make it easier. So we have to use the angle we just found, and that angle is corresponding to the side of 1,583 miles. So the ratios go side over angle of corresponding side. So A over sine A, or C over sine C. In this case, 1583 over sine of 71. Now that's set equal to another ratio, and we can pick that ratio in this case. I just picked P, for example. So 1583 over sine 71 is equal to 448 over sine of P. So when we do this, we got to take cross multiply, and what that says is 1583 times sine of P, which is right here, is equal to 448 times sine of 71.5. So those are your numbers. Now, from that cross multiplication, we want to get sine P by itself. So we take this number on the right divided by 1583, and check your work. You should get sine of P is equal to 0.2684. And when we do that, we take arc sine of both sides. We get the angle to be 15.57 degrees. The last thing we can do is use the idea that angle A is really 180 degrees minus the other two angles, minus 71.51 minus 15.57. And when you run your math and all of your numbers, you find that that angle is 92.92 degrees. We have answered all three boxes, blue, green, and magenta. We've answered the determining angles of all the triangles. There you have it. My 15-minute video, by coincidence, is now half. I am glad it worked out that way. If you have any questions on any of the videos, please let me know. Otherwise, I will see you in class. Thanks.